Hi, we're going to insert separators between groups of 3 digits, so that's like the thousands, in an integer that's given to us as a character vector. I'm going to go through a few different approaches, 3 approaches here, but there are many other ways to solve this, so have a look at the link to the chat event in the video description for more. Okay, let's first generate some test data. So it doesn't really matter what the digits are. Let's raise 10 to the power of 0 through 9. And then we can make each one of these numbers into a character vector. You can't actually see the difference for that. But yeah, they become boxed like this. And that's called that t. And then the separator, it doesn't matter what it is, just any one character. Here's a comma. Okay, so whichever way we do this, we have to start kind of from the right, finding groups of 3 digits. So let's apply this anonymous lambda to each one of the t with s as left argument, and then we reverse the argument. That allows us to work from the left instead. And what we actually want here is a grouping. So we can use the partition enclose function to group. And the way it works here is that we're giving it a mask. So we're going to generate 100100 and as a mask, and the ones indicate beginning a new section. And how many elements do we want? Well, if we take the number of elements in the right argument, that gives us the length. And if we then reshape this and reshape a 100, then we will use those numbers cyclically. So this gives us 1 and then 10, 100, 1001, and so on. And that's exactly what we want for our partition enclose. And we just have to remember to do it on the reversed digits. So this gives us our groups. Now we can add a separator to the front of every group. In this, and then we just need to remove 1 from it because we have one more separator at the end that we don't want. And the last step is then reversal again, and that gives us the results that we want. So let's call this one F. So this is one way to do it. It's just making these groups. Another way to do it is to reach for the regex sublanguage. So let's try that. Again, we want to work from the rear. We could use the regex engine to with look aheads and look behinds in order to work from the rear, but it's much easier to just reverse. And then we want to replace, and we want to replace any sequence of 3 characters, which is going to be digits, so there's no reason to specify that have to be digits, except for the very end. So this is a negative look ahead, to say. So we look for any 3 characters that is not followed by the end of everything. And replace that with the match followed by the separator. That gives us this reverse thing, and then we can just reverse and be done. Let's call this G. And finally, a more APL way of doing this. So let's look at what happens here. Again, we need to work from the reverse, but now we're going to split up into groups while keeping this flat. So it's going to be similar to the partition enclose, but we're going to reshape into a matrix. So we're going to have 3 columns, and then the number of rows. How many rows do we want? Well, it might not be divisible by 3. We can certainly divide the length into 3, and then we need to round up to make sure that we have all the digits. Oop. It's missing a reshape here. Okay, so now we can see that we have reshaped and reused the digits. So if there's only one digit, it gets filled up into 3 here. This is a 10, this is 100, and here's 1000, the last 3 zeros followed by 1 over here. And then we're recycling the digits over here. But we're going to strip those extra digits at when we're done. Okay, now that we have a matrix, we can take the separator and concatenate on the right. So it gives us a column of separators. And then we just need to flatten everything and remove some trailing characters. We can see here we need to remove 3 characters here, 2 here, 1 here, and then 3, and then 2, and then 1. Okay, so we need to find out how many characters do we need to remove. Now let's just concatenate that number as we are computing it. Well, it has something to do with the length, as we can see. And it goes in periods of 3. But this counts the wrong way. Here, this says remove 1, remove 2, remove 0. 1, 2, 0. We really want to go down because we want to do 3, 2, 1. And we could do this with a subtraction, but we could also just negate the right argument to the remainder. So now it says we need to remove 2 and 1 and 0. So this is just off by 1. So we just need to add 1 more to this. However, in order to remove from the rear, we need to use the drop function. And then we need to have a negative left argument. So instead of doing 1 plus this, we can do negative 1 minus this. And that strips the excessive characters, and then we can reverse. And it gives us our result. Okay, so which method is better? This one is a bit more involved, and depending what you need, if you just need brevity or maybe some clarity, straightforward way, or maybe you need high performance, then you can choose between these. Let's look at how the performance compares. So we're copying in the CMPX facility from the defense workspace. And then we need to have a very long number, so we actually need to split up into a lot of digits. Let's say a million digits. So let's just take the first digits of that. You can see this. So it's just 0, 1, 2, 3. It doesn't matter because it's just any characters. Okay, and then we need to compare the execution of the separator Fn and separator Gn and separator Hn. You just need to wait for it to actually do this. And we can see that using the array-based approach, the flat array-based, is definitely the fastest thing you can do. Then, if you have to use nested arrays, do that, and resort to regex if you really can't figure out a different way to do it without regex. Thank you for watching.